approaches we are following to make our machine intelligent and exhibit the intelligent action. All these approaches are coming in a one umbrella, and that umbrella we are calling a soft computing approach. Actually, what is happening if you just see the scenario? We have the several real world problems, and these problems are supposed to be solved by the machine. And among all these real world problems, only 25% problems are the problems which can be solved with the deterministic approach. At least to say that to solve them, we have a precise model or an existing model or a well-defined equations, and we can solve them with the computation, and we call that approach of computation as the hard computing. On the other hand, we have the various other types of the problems, and these problems are containing the uncertainty in the outcome. It means that we are not sure if we have the inputs, what will be the expected output. So we can call the term as the uncertainty. And it has been seen that uh, that uncertainty in the nature of the problem is occurring. The main reason which has been identified initially was that if the problem outcome or the nature of the problem is containing the randomness, and that means that due to that randomness, the uncertainty can occur. It is okay, and we have the so many approaches for handling such type of the uncertainty in the statistical approaches. On the other hand, we have the such type of the problems where the outcome is uncertain, but there is no randomness in the nature of the problem. It means that we are sure the event will occur, but after the occurrence of the event, what will be the expected output? It is uncertain, and so for handling such type of the problem, obviously to handle or to find the output from such type of the problems, we require the approximate reasoning. So now to accomplish the approximate reasoning or to achieve the approximate reasoning with the help of machine intelligence, we have the approach of the soft computing. So now here we are. So it has been now realized that for complex real world problems, we require the following thing, that it means that we should have an intelligence system, and that intelligence system should contain the knowledge, the techniques for handling the knowledge, and the methodologies. That methodologies which we have here is the methodology of the soft computing. So now we can just see that what the kind of the computation we have in the soft computing. So in the word of the Professor Jadev, we have the another approach in computation which is contrast to traditional hard computing approach, and this approach is required if we have the imprecision, uncertainty, and partial truth. And we have the several resources inputs, and these inputs are conflicting with each other. It means that whatever information we have about the inputs, this information is incomplete. So now with the imprecision, with the incompleteness in the input information, or with the partial truth and partial false, we have the requirement of the approximate reasoning. And for handling such type of the problem, we are following the approach of the soft computing. So here we have the component of the soft computing. So as I already told you, the soft computing is actually be required to accomplish the task of approximate reasoning, and we have the two approaches for handling the approximate reasoning. The very first approach is the probabilistic reasoning, and the second approach which we are using is the approach of fuzzy logic. To apply the solution state or to obtain the optimizes or to optimize solutions by exhausting by exploring the exhaustive search space, we have two approaches. One approach is the neural network approach, and another is the evolutionary algorithm approach. Actually, if you just see the literature of the neural networks, it is actually being used for finding the optimal set of weights from the weight space. It means that we have to apply a searching method or a systematic searching method, and that search could able to obtain the optimal weight and to include the optimization to maintain this large of the space with the facility that I could find an optimum solution. We are applying the evolutionary algorithm in the combination of neural networks. So here we can say that if we have the some methods, and these methods are a combination of the neurofuzzy, neuro-GA or the neurofuzzy GA. So if we use the method in combination, then we can call these approaches as a soft computing approach. So now, as I have already told you, we have the following approaches for the problem solving. An approach is the hard computing, another approach is the soft computing approach. And the hard computing approach consists or it is used for handling the those type of the problem where we have the precise model in existence. So we have the symbolic logic reasoning or additional numerical modeling and searching approach. And on the other hand, for the soft computing, we should have the approximate reasoning, or to not to find the approximate reasoning, we should have the approximate models, and these approximate models are able to find the approximate reasoning as well as the functional approximation and the randomized search. So it is the area where we are now focusing. If we further classify the various part or component of the soft computing, so now we can see what are the various models are existing in this umbrella. So now as you can see on the screen, we have the probabilistic model, we have the multi-valued and fuzzy logic, we have the approaches of the neural networks, and we have the approach of the evolutionary algorithm. And if we further go inside it, we can see that we have the so many other approaches. On the other hand, if we see that the neural network itself is containing so many approaches, either we are applying the feed-forward neural network, radial basis network, single or multiple layer perceptron architecture, recurrent neural network, and most commonly the Hopfield type, the self-organizing map, and the adaptive resonance theory. All these are the approaches or the models those are existing for the neural network approach. And on the other hand, for the evolutionary algorithm, we have the so many evolutionary algorithms available in the literature, and the most commonly approach which we are incorporating with the neural network to optimize our search space of weights of the neural network. It is the genetic algorithm, or sometimes nowadays most of the people are using the generative programming. So that it means that we can say in the nutshell, the integration of neurofuzzy approaches together with certain derivative-free optimization techniques. So here I have written the word, whatever evolutionary algorithms like the genetic algorithm we are using in the operation of the neural network, these approaches are the derivative free. It means that the evolutionary algorithm for the any radial descent based approach. So now we can say they are derivative free approaches, and the integration of all these approaches is considered as the soft computing approach. Now here is an example which you can see, and the example is very interesting in a sense that we have a combination of the two things here. The as a part of the soft computing, we have the first component is here. It is the neural character recognizer. We are anticipating, or we are considering this architecture in a way. It is a neural network architecture recognizer, and that neural character recognizer has been trained for recognizing the individual English alphabets, whether the alphabets have written in capital or in the small letters. Here we have a knowledge base, and that knowledge base is containing the knowledge about the various domains and the environment, and it is using the fuzzy inference rules. So now when the input is presented, and you can see the input is D, here input is O with a comma. Comma is considered as an error in the input, or the noisy form of the input, or the errorless input. And third one is the G. So when the neural character recognizer accept the input, it generates the outputs after recognizing these alphabets, and it recognizes the first letter as a D, third as a G, but second it confused, and it indicates, it recognizes that it is either O or it is either A. When these two outputs are provided to our knowledge base, which is using the fuzzy inference system, and now it uses the domain of animal and find the inference that the dog has highest membership in a knowledge base of the animal with respect to the that. So now that word, as for concern of the animal problem domain, should be the dog. It is a way that how the word has been recognized and how the meaning of a word has been identified. It is the strength of the soft computing. And now here obviously you can understand it is the way by which we are handling the approximate reasoning type of the problems. So now it is a complete goal of AI in the soft computing, that what actually has to be happen, and now what the type of the architecture is required. So if you just see on the screen, it is an intelligent system, and this intelligent system is containing so many components. It is a sending device, it is for the vision, it is accepting the inputs, NLP part, mechanical device for the action, and then knowledge base. And here is the important part, which is the part of the machine learning, and that part is actually being deliberately dedicated to the neural network part. It means that our machine has to be trained for the knowledge of all the information, and according to that, it has to be respond in the terms of the recognition. So it is the just difference between the soft computing approach and the conventional AI approaches. So methodology those we have with the soft computing are the approach of neural network. It is being used for the learning and the adaptation. It is its strength. The fuzzy set theory and the strength in knowledge representation via the fuzzy if they rules, as I have already told you in the previous example of the dog. The genetic and simulated annealing, these two are the evolutionary algorithm, and their strength is that they are providing a systematic random search if we have the very large search space. And whereas the conventional AI is actually being used initially for the symbolic manipulation. So now we have the alternative search techniques, and they are provide less optimal solution, and these two approaches are the genetic algorithm and the computer annealing. So it means that both these approaches are actually supporting the randomized search, but that randomized search is being systematic way, and these two approaches are not using any gradient based approach for the optimization. So now we can say that the outcome of the techniques used in the soft computing are actually being used for solving the various real world applications. Those are by nature containing the uncertainty due to the imprecision in the input, and they are handling these problems very effectively and very efficiently. So now here we can just see the example, and here the two figure I am showing to you. In the first figure you can see that we have a robot, a mechanical device, and in the second figure also we have a machine, a machine which is the robot, you can say. This robot is being trained with the human being, that how the human can walk and how the human is able to pass the obstacle. From that adaptation and from that learning, this robot is able to walk just like a human, and this robot is also able to pass if any obstacle is encountered. So now you can see that video and realize what is the strength of the neural network in the terms of the training, learning, and the adoption. Now you can see how the robot is able to walk and see again it, and how it is able to pass the obstacle. Now, in this figure or in this video, you will see that we have a robot or a machine, and that machine is being trained with the swimming style of a fish. It means that in a deep sea, how a fish is able to swim. From that learning and adaptation, that mechanical device is also able to swim, and it creates a scenario that a fish is swimming in a deep sea. So now you can see that video also and realize how the things is happening. So now it is not a fish, it is a machine, and that machine has been trained with the swimming style of a fish, and now you can realize that how the neural network is able to create an artificial life. Now it is another example, or you can say the application of the neural network for recognition of the images. So now here you can see that we have a neural network, and that neural network is being trained to recognize the images of the individual alphabets and all the digits from 0 to 9. Once it is being trained, a car number plate is there, and that image is shown to the neural network which is being trained for the images of the alphabets and the others, and it tries to recognize it. Now you can see the input image. That input image is very blurred, and the characters are not very easily readable. When this image is being accepted, it recognizes it scans the image, it reads the image and try to recognize what is the contained in the image, and it identify that the first letter is M, and the hyphen, and the I980, and you can see that the result of recognition is this. Now, if you see the actual car number, and now it is here, you will see it is M-XZ 9980. So now you can see the accuracy is there, but that accuracy is not 100%. It should be the Z, but it recognizes it as a 2. It means that it is a human common sense. And the human common sense is that the first three should be the alphabets, and after that, there must be the digit. But unfortunately, that common sense is not available with our trained machine. It confused in the two and the chat, and it reads it as a two. It is the reason that in the research of the artificial intelligence and in the research of the neural network, nobody is claiming that the efficiency or the accuracy of the neural network is 100%. All the research papers, all the research says the accuracy is reaching up to 98%, 96%, and so on. It is the reason that, and the reason is very obvious, and reason is that the neural network is able to handle the approximate reasoning, and if we are handling the approximate reasoning, it simply means that we cannot say it will be the 100% accurate answer. Okay, so now we proceed, and we have to ask the various questions. Questions are like that: okay, if we are interested to make a computer machine, and that computer machine should able to trained just like a human being with the set of examples. It means that we are not saying that we have the explicit rules. We are not saying that we will follow the some searching approaches or the some heuristic approaches to find the recognition type of the work. The recognition cannot be happen with the explicit rules, or it cannot be happen with the searching approaches. It can happen as the human is able to recognize the objects. First, it has to be trained, and when it has been trained for some training examples, only then, when any one of the similar type of the pattern of sample is presented as S pattern, and the performance on the S pattern reflects whether we are able to recognize the object or not. The same thing or the same argument is supposed to be applied for the computer machine if we are trying to train the machine in a similar way, in the same manner as the human is going with the training process. So now the important component of the computer machine or for any neural network architecture, that there must be the facility of the learning over training. So once the neural network is trained, only then we can expect that it will able to do the recognition type of the work. So now, how to accomplish, how to incorporate the learning facility in the neural network? It is a challenging task. So now we understand what are the and what are the various the topic of the neural network and see how this artificial neural network is able to explore the abilities of learning and how it is able to learn or train with the presented samples or training samples, and once it is being trained, then what is being expected from it. So now here we have the issue. The issue number one says the artificial neural network should incorporate an approach, and that approach should like that there must be the facility to extract the relevant feature from any input data and reform the pattern recognition task. Now it is a very important issue. Issue is important in a sense. If you see the tendency of work for a human and a computer machine, human works on the patterns and computer works on the data. Computer machine cannot work on the pattern and human cannot work on data. The pattern and data are the two complementary things. For computer machine, everything is data, and for human being, everything is pattern. So now, if we are interested to train our machine in a similar manner as the human is supposed to be trained for the samples, then obviously the artificial neural network should be trained for the patterns, irrespective what is being perceived by the machine as a input data. So now there must be a mechanism by which the computer machine is able to extract the relevant or the necessary or required information. Those are being used to uniquely identify the input, and we call that information in a representation way as a pattern. So now we can understand the word pattern in a sense. If we are able to identify any object in a input space or in a future space, and each space of the future or the input is representing one of the attribute by which that pattern or that input is uniquely identified. It means that if we combine all these attributes and represent them with a single way, it is called the pattern vector. So now the first requirement for the artificial neural network is that it will accept the input pattern vector for the training. So if we have, for example, if I have an example for you, if we have a fruit, any fruit, and we are interested to recognize that fruit, whether it is apple or the orange. Here, for example, the First thing is that for a computer machine, it is the input data. The input data is a fruit. So now the issue is how that input data as a fruit will represent to the machine, though the computer machine and be trained for the particular fruit and identify or recognize it. So what we do, we represent the fruit, any fruit, in the terms of its unique attributes. There may be several attributes in a fruit, but for an application point of view, for convenience of fruit only with the three fruit input presented in a input space of three dimensional. One dimension is the shape, second dimension is a weight, and third dimension is a texture. So now the fruit is being represented as a future vector, and that future vector is containing three attributes. So now you can say we have the three-dimensional pattern vector for the representation of a fruit. And these three attributes are shape, the texture, the weight. And it means that we have a three-dimensional input space of feature space, and along a one dimension, one attribute is represented. And if you consider any point in the three-dimensional input space, it will be a vector. So now for every root information, we have a 3 cross 1 input pattern vector, and that 3 cross 1 input pattern vector will be used for our training. So now the pattern has been extracted from the input, and that pattern vector will be used by the artificial neural network for the training, and once it is being trained, only then it can perform the task of pattern recognition. The second issue is it will learn from examples without any explicit rules. It simply indicates we should have the several patterns of the same information. So now if I have the alphabet A, so I have the alphabets of so many ships. All are A's. All are A's means they all are sharing the common features. So all are sharing the same pattern information, but these are the different pattern samples. And we call them as the examples. So now we should have the training examples, and these training examples are presented to the machine, and the artificial neural network will train for the example, and there is no explicit rule for the pattern recognition. It is some trends in computing, and now it is only for your demonstration that how the things have been changed. From the technology point of view, we have started with the mechanical devices. We After that we have vacuum tubes and so on, and now we have the optical devices. The similar thing we can see in the software. The software changes are like that. We have started with the machine language, and we have the assembly, then high level, then the symbolic programming like Lisp and Prolog, then the fourth generation language, and now from the object oriented to Java, and now we have the environment where we can do the programming in the natural language. MATLAB is a mathematical or technical programming environment, and I feel it is more nearer to the natural language because most of the function names are the similar as we use in our natural languages. It is the changes from the architecture point of view. We have started with the unique processor. We have then after we have the array processor, and then so many things, supercomputer, parallel computer, and now see the point number G. It is the computer architecture which is called the parallel distributed processing models, or PDP architecture. Now, if you just see the parallel distributed processing architecture, the similar kind of the architecture, we can anticipate that it is working in our human brain. I have a reason to say this point because if you just realize as its answer, right? Our receives any input information, it is not happening is in one part of our human brain, other part of the input is on the other part of our brain. It is not happening. So what is happening? The entire input which is being received is distributed throughout our brain to individual processing units. Those are called the neurons, and these neurons process this accepted input information in parallel way. So now it is just resembling with the architecture of the PDP. So now we feel it is the most suitable architecture which should exist for the construction of artificial neural networks. It is the changes in the concept of AI. Initially, computer was invented to do the numerical processing type of the work. And now, as the AI progressed, we have the symbolic processing, and now we have computational linguistic, and we have the NLP, knowledge representation, expert system, hidden marker models, and now we have the approach of artificial neural networks. If we just move forward, just try to think that how the change has occurred if we are working with the neural network approach. So here the two diagrams are demonstrating you that how the things have changed. In the first diagram, you can see we have the computer and it happens in the additional programming. We have the input data. We should have a explicit computer program written in any high level programming language. That program executes in a computer, and when it executes it accepts the input data, and for this input data it produces the output. It is the way which we are following in our additional programming approach. On the other hand, if we see the programming approach of the machine learning or the neural network approach, the things have changed. We don't have any explicit computer program. So what do we have? We should have the input and the output data. It means that you can understand we may have the input output information or past information, previous information, or some sample examples, and these sample examples are containing the input and the output code. So now we can say the other words, we may have input output pattern layers, and these input output pattern layers are presented to the computer machine, and computer will try to capture the implicit function relationship which is existing in the input and the output pattern layers. Those are being used in the training phase, and when it is able to find out or capture that implicit functional relationship between input and the output, we will say it can find the output of any unknown input also. So now we have the explicit computer program which is being provided or generated by the computer machine after going through the rigorous training of this input output pattern pairs. So now it is the approach which we are following in almost all the neural network architectures. So now the requirement is what? We need the input samples, and we also need a system, and that system should adopt some learning methods, and that system has to be trained, and it has to be trained with the learning mechanism. And once it is being trained, some unknown input patterns are presented, and now we call them as the testing phase. And for the unknown input patterns, the result should produce by the trained machine, and to see the result we can understand or he can realize whether it has been trained for the environment or not. So now it is a very simple approach, and the approach simply indicates input samples means we should have the training sets. The system should be trained, and once it is being trained, it has to be tested for the pattern samples or the unknown input samples, and prediction is being produced there as an output. So now it happens in the training and testing. The training set means that we have the explicit input output pattern pairs for them. The training is happening now here. You can see it is a observed one. Now, when any unobserved means that a known pattern is presented, now it has to identify where this unknown pattern will belong, here or here. So if it is rightly belonging, only then only then we can say it is correctly recognized. Now, to maintain the performance of the neural network, we should have the following parameters. The type of training which we are providing to our machine, the form and extent of any initial background knowledge. It means that from which prior knowledge the neural network should start. Once it is producing the output and that output is presented to the environment, the feedback from the environment may also be used to accommodate or to make the learning more accurate or more effective, and the training algorithms. And the two important factors, those are guiding the way in which neural network will work. The one approach or the one factor is the modeling factor, which type of the modeling we are using and which type of the optimization method we are using to maintain our search space in a way that we could find a optimal weight vector. Those are the correct solution for our training, or those are required for convergence of the neural networks. So now we can say the success of machine learning system or the neural network system depends upon the algorithm, and the algorithm controls the search to find and build the whole structure. As I already told you, the learning algorithm should extract useful information from the training examples. It is also been discussed with you. So now we may have the following types of the training or learning algorithms, and you can see it may be the supervised learning, it may be the unsupervised learning, it may be the semi-supervised, or it may be the reinforcement type learning. So any one of the learning we may use, but the question is which type of the learning will use for which application. So obviously the type of model and the type of learning is totally depending which type of the problem or pattern recognition we want to perform by our computer machine. So if we have the task of addiction, classification, or the regression, obviously we are supposed to use the supervised learning. And if we have the task of clustering or some association, dimension reduction, we have to use the unsupervised learning. And for the decision making, like the robot or the chess machine type of the problems, we are supposed to use the reinforcement learning. Now it is another scenario which we have. Now if you see the slide, and now you will realize in a slide here, you will see that we have the data, and this data I have written as a structured one. And now on the other side of the slide, you can see this is the unstructured data. Now, if we have to find any useful information or if we have to do any information retrieval, obviously you have the answer. It is convenient. It is very easy if we have the data in the structured form, and it is true. If we have the data in the structure form, we have the so many tools are available in computer science or in the statistics by which we can find the useful information. But the problem arises when we have the data in the unstructured form. So now you can see it is a picture of the some space type figure or from the satellite image. It is the information which we have from the social media. Now you can understand in a 1 second, in a 1 minute, sorry, we are emerging the uncountable information on our social media through the Facebook, email, WhatsApp, and so on and so on. The issue is that if we have a such large amount of data is available, then how we will able to extract or how we will able to retrieve the useful information and how this large information will be used for decision making. So now it is very hard to do all these works through the manual process, or it is very hard to do for any human being. So it is the real areas, real applications areas where the artificial neural network is required for the decision making and for the recognition of hidden patterns as well as for the information retrieval. Okay. So now all those issues I have already mentioned with you, so I am just skipping it and now I am focusing here. So now to do the pattern recognition by the computer machine or through the model of artificial neural network, if the artificial neural network is able to do any one of the following tasks, we will say it is able to do the pattern recognition task. Either it is able to do the pattern association, pattern classification, pattern mapping, or pattern clustering. It means that a object is recognized with the other object. Example is that A for apple. So now I am recognizing the alphabet A with the apple or apple with the A. So now this is called the pattern association. Or you can say you can recognize the name with the face or you can recognize the face with the name. On the other hand, you have the pattern classification. It indicates that individually each pattern is different from each other. But all these patterns are at least sharing some common feature. On this basis, they are put together in a one class. If, for example, it is the class of Indian, it is the class of American. So now you can see each Indian is different from the other Indian, but a common feature is that they all are Indians. So now if we are identifying the objects according to their unique feature, individually objects are different. If I can say that the fruit and vegetables are separated, each fruit or pale orange, others are different from each other, but they all are sharing the common feature, and it is that they all are fruit. So if we are able to do such type of the recognition of the object, it is being known as the pattern classification. If the artificial neural network is able to capture the implicit function relationship which exists between input and output pattern pair with the help of presented training set. Then it is doing the task of pattern mapping and it is also being considered as the pattern recognition task. On the other hand, if we have the unsupervised way without already pre-specified classes and still we are able to separating the patterns as per their common features, it is called the pattern clustering or pattern grouping as a one of the component of the pattern recognition. So now what we require to do the task or of the pattern recognition. So now here we have methods of pattern recognition task. The first thing which we require is the sensors to collect data from the environment. The third we require is the feature extraction from the data, and fourth we require is the neural network is either able to do the association, storage, classification, grouping, mapping. If any one of these tasks is happening, we will say the computer machine is able to do the recognition type of the task. Now, whether we can see that we have already defined all these words, so I am skipping these slides here. All these things I have already discussed with you, so it is the just repetition. So I am just skipping all these things, and I come to the main objective. This is all okay. Now it is an way to show you how we can model the functioning and working of the actual biological neuron on our sequential machine, and we called it as the artificial neuron. So here you can see we have the external inputs, and now you can see I am representing the input in a vector form. So I have already told you it is a n cross 1 vector. That means that input data for which I have the input are actually representing the future vector for the input. So now I can understand that we have the input and that input has the n feature. So now the reason that I have represented it in the terms of the n cross 1 vector. Here is the artificial neuron or a processing element, and every input is associated with a weight. And now we multiply the input with the weight, and we add all of them. Bias or threshold is a resting potential helping mechanism in a actual neural network system. So here we consider it as a bias weight, right? That bias weight is assigned to the input, and we have fixed that the bias input will always remain on. So now we fix it with the value 1. All other input may have 0 values also. So now you can understand if any one of the input is 0, the weight of that input will become uncommon or it has no use. But here the input is always present. So now bias weight will every time will be active. All these informations are multiplied and added. After this addition, we have the activation of the neuron, and when this activation is passing through the some activation function, it generates the output. So now we call it is the actual activity or actual output which is produced by the neural network. So now you can see here is the S as an activation, which is this emission from J equals to N weight multiplied with the input, and here the G is the sum activation function, and this activation is passing through the function, and we are getting the outputs. Now the point is that what should be the shape or what should be the characteristics of this activation function? We have so many type of the activation function. Those are being used in the literature of neural networks, like the stressing function, hard limiting function, binary function, bipolar function, linear unit function, and we have so many functions depending which type of the problem we are trying to solve. According to that problem, we will decide which type of the activation function we have to use for the activation to generate the output of the neuron. So here some of the common activation functions Those are very frequently being in use. So now you can see them. It is the hard limiting function. So if it is happening, activation is more than zero, output is one, otherwise output is zero. So it is called the hard limiting. So it is a binary outputs, and now we can also find the bipolar outputs are using the same function hard limiting. If I just had the mechanism, if S is more than zero, output is one, and if S is smaller than zero, output is minus one. It is the another function which we have, which is called the expressive function or the sigmoid function. So now it is a S-shaped function. It is a continuous but non-linear, right? So now you can see that the here the activation function is equals to 1 by 1 plus exponential minus activation. So now first type of the function are also used. So now it is totally depending which applications we are handling according to the our application or problem. The selection of activation function is there. In the MATLAB environment, we have so many functions of this as an or as an activation function. So any one of the function we can select. Again, argument is same. Which type of the application or which type of the problem we are handling. So we have hard limiting functions, symmetric hard limiting, linear, saturating, linear, symmetric, saturating, symbiotic, hyperbolic, poetic, linear, and competitive type. So all these functions we can use, and we can just find the output as per our requirement. We have the initial three types of the models. It is called the backlog with models, perceptron model, and the adline, adaptive linear models. So initially, these three types of the architectures or the models of artificial neural network have proposed. Among these three, the McLaughlin model is a initial model, but it is failed to show any ability of to learn from the training set. So it is maintaining the fixed weights. So now it is not being used for the training and the adoption. The perceptron model was the very first model which exhibit the training from the training sets, and it is able to adjust the weight in order to adapt the change in the pattern environment. And Adline is following the gradient based approach for adapting the weights. We can further increase it or improve it, and we have the single layer feedback network. It is the example of the perceptron. And we have the multi-layer feed forward network. It is the example of your back propagation algorithm, and it is opening the door for the deep learning also. And we have the recurrent type architecture, where we have the output works as a feedback of input. So now Hopfield model is a very common approach to just implement the neural network by following the recurrent approach. Now it is the change in the architecture. Now you can see how the weights are being used, how inputs have been used, and how we are able to find the outputs. Now we can extend it. It is the four layer. It is the input layer, it is the output layer, and we have introduces the two more layer here. It is called the hidden layers. And now it is the multi-layer feed-forward neural network architecture. Now, if we extend this idea, now if we try to introduce more layers, hidden layer, and now ultimately we have the deep neural network, and that deep neural network is a very powerful tool nowadays to handling the complex pattern recognition I asked specifically for the image recognitions. So it means that we just see that how much Differences have occurred from the classical neural network approach and in the deep learning approach. In the initial systems, we have the input and we have the hand design program, and the output we have already seen it. In the approach of neural network, we have the input, we have the more step was there, and this step was to hand design feature extraction. It means that first we have to extract the features. After extracting the features, we were constructing the pattern vectors, and these pattern vectors were presented from a training, and from the training we are finding the output. The change that occurred in the deep learning is that we don't require any hand design feature extraction approach. If we include or if we introduce more number of hidden layers as a evolution layers, you can say, and these hidden layers are itself extracting the feature from the input. It means that in this case, the input as a whole is presented pixel by pixel, and these hidden layers are extracting the feature itself. And after extracting the features, the training is accomplished and we obtain the outputs. So it is just example which we have in the deep learning. Now you can see that we have an image. And now, without doing any pre-processing, without doing any feature extraction, this entire image is presented to the input. So now, pixel by pixel image is presented to my input layer. Here I have the first step of the hidden layer, and this step of the hidden layer is extracting the feature from the input itself, and it is finding the edges of the images. These edges are further passing to the second hidden layer, and the input of this hidden layer are the edges, and now it is producing the contours or the corners. And now it is the third hidden layer which is accepting the contours, corners, and producing the objects, and it is a layer from which we are recognizing that in a picture we have a car, we have a person, and we have the animal. So now you can just realize the strength or the power of the deep learning, and we can think how it is able to do multi-object classification. That in one image we have more than one object, and all these objects have been recognized. It is the strength, it is the power of the neural network, that how it is being evolved with itself. By using some extra hidden layers, we are able to do such a complex recognition type of the work. Uh, Abhishek ji, how much time is allotted to me?
We have sir 10 minutes more.
Okay.
10.
So I will try to summarize it. Okay. Now it is another example which I am showing you, and it is the example which I will try to correlate with my first concept of the approximate reasoning. I have already told you that we cannot say the accuracy which we are obtaining through the neural network is 100%. Now here you can see, here we have a deep learning network which has been trained to recognize the animals. That now you can see the training sets are here. The training sets are complete images of the animals. Once it has been trained, a unknown input image is presented, which is here. It is the unlabeled or an unknown input is presented. So now you can identify it as a test pattern set. Now, when this input image is presented, it finds the edges, the contours, and extract the objects and identify 10% times the wrong answer, and 90% time the right answer. It recognizes it as a dog 90%, and it recognizes it as a wolf only 10%. So now you can say the accuracy of recognition for such type of the application is the 90%. Okay. Now it is the platform which we have available as an open source. You can find the so many sources where these platforms are available of the Python framework. So in a Python framework, these are the open environment where you can apply your method and use their libraries and implement the architecture and train them and obtain the result, and they contain so many pre-trained architectures. Now, if you just open the library of NPI, you will see they have several models or architecture of deep learning neural network, and these architectures are pre-trained. They are already trained. You have to only pass your input information according to your application, and the classification, the things will happen automatically, and it finds the accuracy, and it will also create the infusion matrix from which you can find the analysis and see how the accuracy, how the predictions are available. So I think I have explained you so many things, and I hope issues. So now I stop myself, and the questions are welcome here.
Many thanks, Dr. Mano Pratap Singh sir, for a very beautiful, very elaborative lecture. Now, participant, you are invited to ask any query. If you have any kind of doubt, you can ask to sir. Please, let me unmute yours, your first of all. Okay, now you can ask to sir if you have any kind of doubts. Participants.
Or you may write the chat. I will reply, or I would.
Yeah,
or I will
you can write in a chat box also, or you can send your queries to me also. Okay. Whatever the queries you have, just please ask, okay, or write in a chat box.
If you have no query, then I feel that the two things can happen. Either you have understood everything, or you have not understood anything. I hope that you have understood everything. It is my approximate reasoning. The rest is yours.
Barkha, do you have any query? Barkha Sahu? Barkha is our research scholar. Barkha?
Okay.
Yes, sir.
Do you have any kind of query?
Not now, sir. Actually, I'm processing all these things right now. But yeah, further, if I have, I will surely inform you. And I would like to learn more and more about these things